Today we shall discuss the JEE Mains 2014 paper question by question and also analyze certain concepts based upon those questions. So now let's move on to the first question that has been asked in one of the series here. Question number 1, it reads like this: if x is equal to 4 power n minus 3n minus 1, n any natural number, and y is equal to the set 9 into n minus 1, n any natural number, where n is a set of natural numbers, capital N is the set of natural numbers, then x union y is equal to first option x, second option y, third option natural numbers, fourth option y minus x. Now our set was x is equal to 4 power n minus of, shall we put it as 3n plus 1, n any natural number. The set y is equal to 9 into n minus 1, n any natural number. You have here all multiples of n, whole number multiples of n. So 0, 9, 18, like that. This is our set y. Let's look at this set x. 4 power n minus 3n plus 1. We can write this as 1 plus 3 power n minus nc 1 into 3 plus nc naught into 1. Let's go by the binomial expansion of 1 plus 3 power n here. That these two appear to be the first two terms of that binomial expansion. So you will have those first two terms cancelled and rest of the terms will start with 3 square. 3 square into nc2 plus nc3 into 3, so on and so forth. So which means that it is a multiple of 9. So this 4 power n minus 3n plus 1 is some multiple of 9. So which means that it's a part of our y. So every element of x is a part of our y. So x is a part of y. So what will be the union of x union y? Will be entire y only. So x being a subset of y here, clearly it implies that x union y is equal to y. So option 2 is the right answer. Option 2 is the right answer. It's a simple thing that we observe here. Use binomial expansion for 4 power n. Observe that these two are the first two terms of that. So when you take out, those two terms get cancelled and the rest of the terms will carry a 3 square as a common factor, which means that all of them are multiples of 9. But this includes all the whole number multiples of 9. This includes some multiples of 9 only. So x is a subset of y. So proper subset of y, in fact x union y is equal to y. So that's the option 2 there. Question 2. If z is a complex number such that mod z is greater than or equal to 2, then the minimum value of mod of z plus half, first option, is strictly greater than 5 by 2. Second option, strictly greater than 3 by 2 but less than 5 by 2, is equal to 5 by 2. Fourth option lies in the interval 1, 2. So let's have the look at the solution here. Mod z equal to 2 will be a circle with the center as origin and the radius 2 units. Center as origin. Mod z equal to 2 is for any point z here. Mod z is equal to 2. This corresponds to mod z equal to 2. Modulus of z greater than or equal to 2 will correspond to points outside and on the circle. That is exterior and on the boundary of the circle. This circle. Mod of z plus half, what does this measure? It measures the distance between z and minus half. So the complex number minus half lies here, minus half comma 0. Now of this region which is exterior to the circle and on the boundary of the circle, which is the point which is closest to minus half comma 0? Obviously this point. This is closest. Alright. A distance, closest distance from a point to a curve is measured along a normal drawn to the curve that is passing through the point. Obviously the normal passing through minus half comma 0 and to this is, or this line passing through origin, therefore this is it. And this point is minus 2 comma 0. So the minimum distance clearly is the distance between minus 2 and minus half. Now that's clearly 3 by 2. That is minus, look at it geometrically here. What is mod of z plus half? It's a distance between z and minus half. Minus half lies inside this circle, circular disc. And now mod z greater than or equal to 2 will be points on the circle and outside the circle. Among those points, among the points in the region, which is the one which is closest to minus half comma 0, and that's clearly minus 2 comma 0. Therefore the minimum distance is 3 by 2. Therefore the option, and 3 by 2 is of course lying between 1 comma 2. So option 4 is the right answer. 3 by 2 belongs to the open interval 1 comma 2. So the minimum value lies between 1 comma 2. So hence the option 4 is the right answer. Let's look at this question number 3. If a is a real number and the equation minus 3 into x minus bracket x whole square plus 2 into x minus bracket of x plus a square equal to 0, where bracket x denotes the greatest integer less than or equal to x, has no integer solution, then all possible values of a lie in the interval. First option minus 2 comma minus 1, second option minus infinity to minus 2 union 2 to infinity, third option minus 1 to 0 union 0 to 1, and fourth option 1 comma 2. Okay. So the solution goes like this. Minus 3 into x minus bracket of x, we can look at it as fraction part of x, square of it, plus 2 into fraction part of x minus a plus a square is equal to 0. And now this should not have an integer solution. So for what values of a, this does not have an integral solution. Whenever x is an integer, fraction part of x should become 0, right? So here that means your fraction part of x should not be 0. Now I will look at this equation like this: minus 3 into, we will multiply by a minus sign and we will have 3 into fraction part of x square minus 2 into fraction part of x minus a square is equal to 0. We can factorize this. This is 3 into fraction part of x square minus 3 into fraction part of x plus fraction part of x minus a square is equal to 0. You can take out fraction part of x common, 3 into fraction part of x common, and you have here fraction part of x minus 1, and we can write fraction part of x minus 1. I will introduce that minus 1 here and take that a square that side and write it as a square minus 1. So we can factorize this out as fraction part of x minus 1 into 3 into fraction part of x plus 1. That is equal to a square minus 1. Now this fraction part of x should not be 0. When is it 0? Let's see. What if fraction part of x is 0? If fraction part of x is 0, this happens if and only if x is an integer. So if fraction part of x is 0, this will become minus 1 and this will become 1, which means that the entire thing will become a square minus 1 will become minus 1. That means this fraction part of x equal to 0 if and only if a square minus 1 is equal to minus 1. That means a square is equal to 0. That implies a is equal to 0. But you don't want fraction part of x to be 0. So that means that this should not happen, this should not happen, a should not be 0. Okay. And moreover, here observe that this part, the fraction part of x is always less than 1. So this will be a negative quantity. This is negative quantity. And this is a positive quantity. So negative into positive will be a negative quantity. So a square minus 1 by choice should be a negative quantity. Should be negative quantity. So a square less than 1, which means that a should actually lie between minus 1 to 1. Open interval minus 1 to 1. But if a were to be 0, we have said fraction part of x will become 0, and you don't want a to be 0 then. Therefore, what is it? A should belong to minus 1 comma 0 union 0 comma 1. So let's have a look at this again. I rewrote this equation and I introduced a 1 both sides so that this can be factorized. Now we have a fraction part of x minus 1 plus 3 into fraction part of x plus 1 is equal to a square minus 1. We observe that this is a negative quantity and this is a positive quantity. The product is a negative quantity. Then come back to this. If the fraction part of x is 0, then x is an integer value. So if and only if, then that means that 0 minus 1 and 3 into 0 plus 1, that will be minus 1. So this will be equal to fraction part of x will be 0 provided a square minus 1 is equal to minus 1. I don't want fraction part of x to be 0. So that means what? X should not be an integer. So a square minus 1 should not be minus 1. A square should not be 0. A should not be 0. But this is a negative quantity, therefore a square should lie between minus 1 and 1. Therefore a should actually belong to the interval minus 1 to 1 with an exception of a being equal to 0. So a belongs to minus 1 comma 0 union 0 comma 1, and the option 3 is the right answer. Option 3 is the right answer. So let's look at the next question, the question number 4. Let alpha and beta be the roots of the equation px square plus qx plus r equal to 0, p not equal to 0. If p, q, r are in AP and 1 by alpha plus 1 by beta is equal to 4, then the value of mod of alpha minus beta is first option root 34 by 9, second option 2 root 13 by 9, third option root 61 by 9, fourth option 2 root 17 by 9. Okay, let's have a look at the solution here. We have a quadratic equation px square plus qx plus r equal to 0 with p, q, r are in AP. So clearly 2q is equal to p plus r here, and he has also given us one relation between the roots here. Alpha, beta are the roots of this roots, and 1 by alpha plus 1 by beta is given to be equal to 4. So from here it implies that alpha plus beta by alpha beta is equal to 4. But what is alpha plus beta? Minus q by p. So minus q by p divided by alpha beta, that is r by p, is equal to 4 here, which implies that q has to be equal to minus 4p. So we can write q to be minus 4p, minus 4r, sorry. It should be minus 4r. P cancels and we have q is equal to minus 4r. Now q is equal to minus 4r. So coming back to this equation, we have therefore p is equal to 2q minus r. That makes it minus 8r minus r. So therefore that is minus 9r. So in the entire equation can be now represented in terms of the coefficients can be represented in terms of r. So what do we have here? The equation becomes p can be replaced by minus 9r and q can be replaced by minus 4r. So minus 9r x square and minus 4r x plus r is equal to 0. So clearly we can rewrite this equation. Minus r can be taken out common and then we have 9x square plus 4x minus 1 is equal to 0. We can cancel out this r here and then we have here 9x square plus 4x minus 1 is equal to 0. We can find the roots of this, and in fact we don't actually need the roots. What we need is modulus of alpha minus beta. Modulus of alpha minus beta is equal to alpha plus beta the whole square minus 4 into alpha beta under root. So what do we have here? What is alpha plus beta? Minus 4 by 9. So minus 4 by 9 whole square minus 4 into alpha beta is minus 1 by 9. So we have here under root of that. So that comes out to be clearly option 2, 2 root 13 by 9, and that is option 2 is the right answer. So a simple calculation will give us this 2 root 13 by 9, and that is option 2. So what? So this equation, which is represented in terms of PQR with the help of these two relationships, that PQR are in AP and 1 by alpha plus 1 by beta is equal to 4, we could bring the equation in terms of one coefficient, single coefficient, that is single parameter is a coefficient here, r in terms of r. So we have the equation like this, and going by the formula modulus of alpha minus beta, it's this. So clearly the option 2 is the right answer. Let's move to the next question, question number 5. If alpha beta not equal to 0 and f of n is equal to alpha power n plus beta power n, and the determinant, first row 3 1 plus f of 1 1 plus f of 2, second row 1 plus f of 1 1 plus f of 2 1 plus f of 3, third row 1 plus f of 2 1 plus f of 3 1 plus f of 4, determinant formed by this is equal to k into 1 minus alpha whole square into 1 minus beta whole square into alpha minus beta whole square. Then the k value is equal to, so let's have options are 1, second option minus 1, third option alpha beta, fourth option 1 by alpha beta. So let's have a look at the solution here. F of n is given to be alpha power n plus beta power n. Now the given matrix, the given determinant, we will look at it this way: 3 1 plus alpha plus beta, f of 1 is alpha plus beta, 1 plus f of 2, that is 1 plus alpha square plus beta square, and then you have here 1 plus f of 1, that is 1 plus alpha plus beta, and then 1 plus alpha square plus beta square, 1 plus alpha cube plus beta cube, 1 plus alpha square plus beta square, 1 plus alpha cube plus beta cube, 1 plus alpha power 4 plus beta power 4. That is our f of 4. The whole thing is given to be k into 1 minus alpha into 1 minus beta whole square into alpha minus beta whole square, and we had to find the value of k. One thing you could do is that alpha beta are both non-zero. You could give some values to alpha and beta and compare and get the value of this thing. For example, alpha could be taken as -1 and beta as 1, and compare, put the values here. You get the determinant on the left hand side, k into something is equal to something, so you can find the k value. That's one method. Rather, we will look at it in a more using some theory here. We will write this as product of two determinants. You know, two determinants can be multiplied with a row with a row, row with row, row of the first matrix with the row of first matrix with the first row of second matrix. So 1 1 1. To get this 3, I will take this 1 1 1 here. Now let's take 1 alpha beta here. So that gives me 1 into 1 plus 1 into alpha plus 1 into beta, that is 1 plus alpha plus beta. So to get this here, I should be multiplying this with alpha square beta square. So I am getting that. First row of the first determinant is multiplied with first row, second row, third row to get these entries. Because we know that determinant of a matrix is equal to determinant of its transpose. So we could even transpose it and multiply as general matrix multiplication there. So here, what about this row? How do we generate this row from here? How about taking this 1 alpha beta? So if I multiply here, I get 1 plus alpha plus beta. Is it matching? 1 plus alpha square plus beta square, if I match, I'll get this. Okay. And then 1 alpha square beta square. This is a standard determinant. This is 1 minus alpha into 1 minus beta into alpha minus beta. So we have this determinant is 1 minus alpha into 1 minus beta into alpha minus beta. So clearly the square of it is what you have here, because the determinant multiplied with itself is what you have here. So k, what is k then? K is 1. Clearly it's 1 into this. So the place of k we have 1. K is 1. So therefore k is 1, and the right option is option 1. Option is also 1. Question number 6. If A is a non-singular matrix such that A into A transpose is equal to A transpose into A, and B is equal to A inverse into A transpose, then B into B transpose equals to, first option B inverse, second option B inverse transpose, third option I plus B, and fourth option I, the unit matrix I. Okay, so let's look at the solution for it. What are we given? Given A into A transpose is equal to A transpose into A. The symbol is transposition of the matrix. What else are we given? We are also given that B is equal to A inverse into A transpose. For more clarity, let me put it as T here. That symbol is same as A transpose, T for transpose. Okay, I am replacing the tilde symbol with T. Now what do we want? We want B into B transpose. This is what we want. We've got to find out this. Okay, let's go about this. What is B transpose? B transpose is equal to A inverse into A transpose the whole transpose. When you multiply two matrices and take the transpose, the order, when you're taking the transpose of the individual matrices, the order will be reversed. So now this will be A transpose transpose into A inverse transpose. So that A transpose, double transpose is A, So A into A inverse transpose, or we can even write this as A into A transpose inverse, because transposition and inversion on the matrix, they are both unary operations and they are commutative. That is, one can be interchanged with the other, the order can be interchanged. So we have here A into A transpose the inverse. Now coming back to this, what you want is B into B transpose. So B into B transpose is A inverse, I am writing B, so A inverse into A transpose. I am writing B transpose, that is A into A transpose inverse. A into A transpose inverse. This is B and this is your, okay, is A, B transpose. Now by associativity we can write this A inverse A transpose A. I will group these two things, middle things, and then I will be left with A transpose inverse. So grouping the middle two matrices, not changing the order. We are not changing the order. So here, but we know that A into A transpose is A transpose into A. So we can replace A transpose A with A into A transpose. So this has been replaced like this by what is given here. That into A transpose the inverse. So what do you have now? By associativity again A into A inverse into A, and you have here A transpose into A transpose inverse. So clearly this is I identity matrix, there is also identity matrix because these two are inverses of each other. So I into I is I. Finally B into B transpose is equal to I. So what we have is that option 4 is the right answer. Let's move on to the next question here. If the coefficients of x cube and x power 4 in the expansion of 1 plus ax plus bx square into 1 minus 2x raised to the power 18 in powers of x are both equal to 0, then the ordered pair a comma b is equal to, first option 14 comma 272 by 3, second option 16 comma 272 by 3, third option 16 comma 251 by 3, fourth option 14 comma 251 by 3. Right. So let's have a look at this here. We are interested in equating the coefficient of x cube and x power 4 both to 0 in the expansion of 1 plus ax plus bx square into 1 minus 2x raised to the power 18. Okay. 1 plus ax plus bx square, let me just copy it as it is. And this 1 minus 2x raised to the power 18, we can write this as 18c naught minus plus of, let's say, 18c1 into minus 2x plus 18c2 into minus 2x whole square plus 18c3 into minus 2x the whole cube plus 18c4 into minus 2x power 4, so on and so forth. Since we are interested only up to the coefficient of x cube and x bar 4, I am only writing up to these terms. We have up to minus 2x raised to the power 18. So that would be the last term there. Okay. Now what is the coefficient of x cube in this product? So how do I get an x cube here? I pick up an x power 0 from here and x power 3 from here. X power 1 term here and x power 2 term from here, and x power 2 term from here and x power 1 term from here. So while picking up x power 0, x power 3, first, second, in the first expansion I look at x power 0. What is the coefficient of x power 0? 1. What is the coefficient of x cube? That is minus 18c3 into 2 cube. So minus 18c3 into 8 into x cube. So what is the resultant coefficient? What do you have? Minus 8 into 18C3. Minus of 8 into 18C3. What about the coefficient of x cube in another way? That is, I look at the x power 1 term here and x squared term from here. So x power 1 has a coefficient a here, and you have here 18C2 into 4 minus 2 squared is 4 into x squared. The coefficient, if you pick up, it's going to be 4 into 18C2 into a. Similarly, the coefficient of x cube can also be obtained by taking a bx squared term from here and x term from here. So what do we have here? 18C2 into minus 2 into x here. Okay, that's going to give me x cube term, that is minus of 2 into 18C2 into b, that into b. So when I'm adding up, when I'm looking at the coefficient of x cube, I have to add up all this. So what do we have here? Minus 8 into 18C3 plus 4 into 4a into 18C2 minus 2b into 18C1 here, 18C1. This is the coefficient of x cube, and that has to be equated to 0. You can find out, you can see that minus 2 is taken common. We have therefore 4 into 18C3 minus 2a into 18C2 plus b into 18C1 equated to 0. Okay, this minus 2 can be cancelled out, and we have here, what is 18C3? We can use this identity, NCR by NCR minus 1 is equal to n minus r plus 1 by r. So we will divide throughout by 18C2. So what we have is 4 into 18C3 by 18C2 minus 2a plus b into 18C1 divided by 18C2. So this is a reciprocal of this identity. What is NCR minus 1 by NCR? That's going to be r by n minus r plus 1. So when it comes to this, where I'm going to use this identity, when it comes to this, the reciprocal will be used here, and that is equated to 0. So what is it? 4 into, what is 18C3 by 18C2? What is in place of n? We have 18, and what do we have in place of r? 3. So 18 minus 3 plus 1 by 3 minus 2a plus b into, I have to write the reverse here. In place of r you have 2, NCR minus 1 by NCR. R is 2 here. So what do we have here? 2 by 18 minus 2 plus 1 is equal to 0. So that makes it 4 into 18 minus 3, 15, 15 plus 1, 16, 16 by 3. Okay, minus 2a plus b into 2 by 17 is equal to 0. So we can frame one more equation with the help of equating the coefficient of x power 4 to 0. We can frame one more equation. We'll have two equations, two unknowns, and clearly a simple calculation will give us that a has to be, so this is one equation. Equating the coefficient of x power 4, we can collect the x power 4 coefficient the same way. X power 0 from the first expansion, x power 4 term from the second expansion. Go on, we'll frame one more equation like this, and solving those two simultaneous equations, we will have the values of a and b, and clearly the value of a is 16 and b is 272 by 3. A is 16 and b is 272 by 3 is what you will be getting by solving two simultaneous equations. One we obtained by equating the coefficient of x cube to 0. Second we obtained by equating the coefficient of x power 4 to 0 there, right. So this clearly the option 2 is the right answer. Option 2 is the right answer. Let's move on to the next question, question number 8. If 10 power 9 plus 2 into 11 power 1 into 10 power 8 plus 3 into 11 square into 10 power 7 plus so on so forth up to 10 plus 10 into 11 power 9 is equal to k into 10 power 9, then k is equal to first option 100, second option 110, third option 121 by 10, fourth option 441 by 100. So let's have a look at this. What is the series that you are given? 10 power 9 plus 2 into 11 power 1 into 10 power 8, okay, plus 3 into 11 square into 10 power 7. So let's guess the next term. What should be the next term here? You see the pattern here, 1 2 3 4. Okay, now let us think that we have 11 power 0 to start with. 11 power 0, 1 into 11 power 0, 0 plus 9, 1 plus 8, 2 plus 7, they are all equal. So the power of 11 is increasing and the power of 10 is decreasing here, but the sum of the indices is maintained constant as 9. So 4 into 11 cube, and what do you have? 10 power 6, so on and so forth. The last term being, what is that? 10 into 11 power, the power of 11 has been enhanced to, it will go on up to 11 power 9, and then what will you have here? 10 power 0, which is anyway 1 there, 10 power 0. This is what you want. This sum, yes, is what we want. Observe that this is in the form of an AGP, that is arithmetico-geometric progression. The first parts, they are in AP, what I have underlined, they are in AP, and the rest of the parts you see that 11, it's getting, every term is getting multiplied by 11 divided by 10. So 11 by 10 becomes the common ratio. So what you do is, the general process is you multiply the sum by 11 by 10, okay, and shift and write it. So what you do is, let me rewrite this, yes, 1 into 11 power 0 into 10 power 9 plus 2 into 11 power 1 into 10 power 8 plus 3 into 11 square into 10 power 7, so on and so forth. The last term, 10 into 11 power 9 into 10 power 0. Let me write like this. So 11 by 10 is the common ratio, it appears. Let's multiply by 11 by 10. Now when you are multiplying by 11 by 10, each term you shift and write it underneath this. So what do we get? 1 into 11 by 10, so you will have 11, 1 into 11 power 1 into 10 power 8, because you have a 10 power 9, when you multiply by 10, 1 by 10, you will get 10 power 8. Next, you will get this term multiplied with this will give me 2 into 11 square into 10 power 7. So this term, when I multiply with the term previous to the last term, I am going to get it underneath the last term now. I am shifting and writing. Shift by one term and write it. So what will you get? The coefficient will be 9 into 11 power 9 into 10 power 0. That matches. Now this term multiplied with the last one will give me, what does it give me? 10 into 11 power 11, 11 power 10 by 10. So into 1 by 10 there. So that makes it, this 10 and 10 cancels and you will be left with 11 power 10 there. So let me put a 0 here. Let me put a 0 here. I subtract 1 from the other. What do we have here? Minus 1 by 10s. Term by term, column by column, let's subtract. S minus 11 by 10 into S, we will have a minus S by 10. And we have here, what do we have here? This is 11 power 0 into 10 power 9. That's 10 power 9. And now this part is same in both of them. So 2 minus 1. So that's 1 into 11 power 1 into 10 power 8 plus 1 into 11 square into 10 power 7. So on and so forth. We'll have 1 into 11 power 9 into 10 power 0. And now this term with a minus sign, it will come with 11 power 10. 11 power 10. This is your minus 1 by 10 times of S. Observe that this is clearly in GP and with the common ratio as 11 by 10. So the AGP has been brought down to a GP here on the right hand side. What do we have? What's the first term? 10 power 9 into R power, that is 11 by 10 raised to the power. How many terms we have here? Up to here. We're looking up to here. So we're starting with 11 power 0 and going on up to 11 power 9. That makes it 10 terms there. So 11 by 10 raised to the power 10 minus 1 by 11 by 10 minus 1. Okay, so what do we have here? That comes out to be 10 power 9 into 11 power 10 minus 10 power 10 divided by 11 by 10 minus 1, that is by 10 power 10 here we have, and we have here 1 by 10. So when we bring this 1 by 10 up, it will become 10 power 10. The 10 power 10 cancel out. This 10 power 10 cancels with this. What you have is this part in the bracket is 11 power 10 minus 10 power 10, and we already have a minus 11 power 10 here. So what is it coming out to be? So minus S by 10 is now turning out to be, it's turning out to be 11 power 10 minus 10 power 10, again minus 11 power 10. So that makes it, this cancels, and what do we have? Minus 10 power 10. S by 10 is this. What is S then? Clearly S is equal to 10 power 11, and that's clearly 10 square into 10 power 9. So that is 100 into 10 power 9. That's what you wanted. So K is 100. K is 100. Therefore the right option is 1. Option 1 is the right answer. Let's move to the next question. Question number 9. 3 positive numbers form an increasing GP. If the middle term of this GP is doubled, the new numbers are in arithmetic progression, then the common ratio of the GP is, first option 2 minus root 3, second option 2 plus root 3, third option root 2 plus root 3, and fourth option 3 plus root 2. Now let the three numbers which are in GP be A, AR, AR square be the three terms which are in GP. Let the GP be this. It says if the middle term is doubled, so what is it? 2AR, and the new sequence will be A, 2AR, AR square. This it says is in AP, which means that That is, when the middle term of the GP is doubled, the resulting sequence, he says, will be in AP, arithmetic progression. So that means that a double of the middle one, that is 4AR, will be equal to A plus AR square. Okay, so we can cancel out A here, and then we have 4R is equal to 1 plus R square. R square minus 4R plus 1 is equal to 0. And what does this say? This is an increasing GP, therefore R must have been greater than 1. Solve for this. R minus 2 whole square. We'll add a 3 here. We'll add a 3 both sides. R minus 2 whole square. Add a 3 here. So that becomes 3 here. R minus 2 is equal to plus R minus root 3. So R is equal to 2 plus R minus root 3. Now R cannot be 2 minus root 3. 2 minus root 3 is a quantity less than 1, but you want R to be greater than 1. Therefore R has to be 2 plus root 3 only, since R is greater than 1. So 2 minus root 3 has to be discarded, and therefore what you have here is that R value is 2 plus root 3. The right option is 2. Option 2 is the right answer. Let's move on to the next question. Question number 10. Limit as x tends to 0 of sine of pi cos square x by x square is equal to, first option minus pi, second option pi, third option pi by 2, fourth option 1. Limit x tends to 0 of sine of pi cos square x by x square. Clearly you observe that as x tends to 0, cos square x tends to 1, this part tends to 1, and sine pi, that goes to 0, so the numerator goes to 0. What about the denominator? Clearly the denominator goes to 0. So it's in the form of 0 by 0, so that is the indeterminate form. Indeterminate form. Let's apply the LH rule. Differentiate both the numerator and denominator. So that comes out to be limit x tends to 0. What's the derivative of sine of pi cos square x? Minus cos of pi cos square x. Oh, sorry, plus cos pi cos square x into pi into, what is the derivative of cos square x? Minus sine 2x. And now the derivative of the denominator is 2x. Observe that as x, whenever you, again this is in the form of 0 by 0. Instead of differentiating, let's see if you can take out the terms that are becoming finite there. So here there is a pi, whereas x tends to 0, cos of pi cos square x will become, that will become cos pi, that is minus 1. So minus pi and minus of minus, that make it plus here, and sine 2x by 2x, that tends to 1 there. So that's finally pi. The answer is going to be pi. That is pi into this pi cos square x, cos of pi cos square, that will be minus pi. And there's a minus sign here, so minus of minus plus here, and it comes out to be limit x tends to 0 of sine 2x by 2x. That's clearly 1 here, this is 1. Therefore we have final answer to be pi, and that's clearly seen in the option 2. Option 2 is the right answer. Let's move to the next question, question number 11. If g is the inverse of a function f and f dash of x is equal to 1 by 1 plus x power 5, then g dash of x is equal to, first option 1 by 1 plus g of x power 5, and second option, that is 1 plus g of x raised to the power 5, third option 1 plus 5 into x power 5, fourth option 5 into x power 4. So let's have a look at this here. What is given? G and f are inverses of each other, are inverses functions of each other. Now clearly f composition G must be an identity function, is identically equal to x. So let's now differentiate both sides, differentiating with respect to x. Using the chain rule, we have f dash of g of x into g dash of x is equal to 1. Okay, so therefore you have g dash of x to be equal to 1 by f dash of g of x. What is your f dash of x? We are given that f dash of x is equal to 1 by 1 plus x power 5. This is given. Now this is kind of a function now of x here. What would be f dash of g of x? That is, wherever there is x, I have to replace it with g of x. So 1 plus g of x power 5. Now this is the reciprocal of that. So what is 1 by f dash of g of x? Obviously the reciprocal of this, and that is equal to 1 plus g of x raised to the power 5. Raised to the power 5. And that is our g dash of x. G dash of x is f dash 1 by f dash of g of x. That is what you found here. Hence g dash of x is equal to 1 plus g of x raised to the power 5, and that's clearly seen in the option 2. Option 2 is the right answer. Option 2 is the right answer. Let's move on to the next question, question number 12. If f and g are differentiable functions in the closed interval 0, 1 and satisfying the equations f of 0 is equal to 2 is equal to g of 1, comma, g of 0 is 0 and f of 1 is equal to 6, then for some c belonging to 0, 1, we have first option f dash of c is equal to g dash of c, second option f dash of c is equal to 2 into g dash of c, third option 2 into f dash of c is equal to g dash of c, and fourth option 2 into f dash of c is equal to 3 into g dash of c. Now you have f and g. F is a function, real valued function. G is also a real valued function on the domain 0, 1. Both are differentiable. By Cauchy's mean value theorem, there exists some point c belonging to open interval 0, 1 such that f dash of c divided by g dash of c is equal to f of 1 minus f of 0 by g of 1 minus g of 0. Okay. All right. So here, what is f of 1? What's given? We are given that f of 0 is 2 and g of 0 is 0. F of 1 is 6 and g of 1 is 2. So let's substitute. F of 1 minus f of 0 will give me 6 minus 2 here, and g of 1 minus g of 0, that is 2 minus 0. So clearly it's 2. So f dash of c is equal to 2 into g dash of c. This is by Cauchy's mean value theorem. We have a point c belonging to open interval 0, 1. Whenever you have f and g to be differentiable functions, we have a situation like this. So option 2 is the right answer. Option 2 is the right answer. Now let's look at the question number 13. If x is equal to minus 1 and x equal to 2 are the extreme points of the function f of x is equal to alpha into log mod x plus beta x square plus x, then first option alpha is equal to 2, beta is equal to minus half. Second option alpha is equal to 2, beta is equal to half. The third option alpha is equal to minus 6 and beta is equal to half. And fourth option alpha is equal to minus 6 and beta is equal to minus half. Okay. Now what is the function f of x? Alpha into log mod x plus beta into x square plus x. This function is a clearly differentiable function on its domain. So for a differentiable function, while we are seeking for the extreme points, we have to look for the points where the derivative becomes 0. So extreme points are possible points where the derivative becomes 0 for a differentiable function. So here let's go for the derivative f dash of x. What is that? Alpha by x. Or what is the derivative of log mod x? 1 by x. What's the derivative? So we have 2 beta x plus 1. Minus 1, x equal to minus 1 is a point of extreme. So x equal to minus 1, at x equal to minus 1, f dash should become 0. So f dash of minus 1 is 0. So what do we have? Minus alpha minus 2 beta plus 1 is equal to 0. That gives me alpha plus 2 beta to be 1. Alpha plus 2 beta is equal to 1 there. So that gives one equation. In fact, clearly the option 1 itself can satisfy this. No other option can satisfy this equation. Anyway, let's have a look at the other one also. At x equal to 2, we have the derivative f dash of 2 also 0. So that will also give us one more equation. So alpha by 2 plus 2 beta into 2 plus 1 is equal to 0. That gives us alpha plus 8 beta is equal to minus 2. So clearly when you solve these two equations, you will get alpha to be 2 and beta to be minus half. This is clearly satisfying both the equations here. Alpha is 2 and beta is minus half, and clearly the option 1 is the right answer. Option 1 is the right answer. Let's move on to the next question, question number 14. The integral 1 plus x minus 1 by x multiplied with e power x plus 1 by e power of x plus 1 by x dx is equal to, first option, x plus 1 into e power of x plus 1 by x plus c. Second option, minus x into e power of x plus 1 by x plus c. Third option, x minus 1 into e power of x plus 1 by x plus c. And fourth option, x into e power of x plus 1 by x plus c. Now this integral 1 plus x minus 1 by x multiplied with e power of x plus 1 by x dx. What we'll do is we'll split this integral 1 into e power, so that gives me e power of x plus 1 by x dx plus integral of x minus 1 by x into e power of x plus 1 by x. You observe that if I put x plus 1 by x as some t here in this integral, I would get 1 minus 1 by x square. But I don't have a 1 minus 1 by x square here dx. dt will be 1 minus 1 by x square dx. Instead I have x minus 1 by x. So what we'll do is we will take out x common from here. This x minus 1 by x, I am going to rewrite it as x into 1 minus 1 by x square into e power of x plus 1 by x dx. So the second integral we are going to modify like this. This will not change it as it is. We will copy this integral. Now this appears to be entire part is easily integrable, because if I put it as, if I put x plus 1 by x as t, this becomes e power t and this is dt. Entire thing becomes dt. So we'll use the product rule. This is the first function and this is the second function. Second function. What is integral of u dv? We know that it's equal to uv minus u dash v d. Okay, u dash v dx. So let's use that here. So what do you have here? E power of x plus 1 by x Now this is like u and this is like dv, the differential of e power of x plus 1 by x. So when I integrate it, I'm just going to get x into e power of x plus 1 by x. U is x and v dv, this is dv, entire thing up to this is dv. So I'll get that minus of, what's the derivative of u? That is 1 into this, as it is has to be copied out. I have x power x plus 1 by x dx, and this, of course, this integral and this integral, the last one, are one and the same. There with a minus sign, they differ by a sign, so they cancel, and we have therefore x into e power of x plus 1 by x, plus of course we should add an arbitrary constant, see there, and clearly option 4 is the right answer. Option 4 is the right answer. Let's move on to the next question, question number 15. The integral 0 to pi under root of 1 plus 4 sine square x by 2 minus 4 sine x by 2 dx equals, first option 4 root 3 minus 4, second option 4 root 3 minus 4 minus pi by 3, third option pi minus 4, fourth option 2 pi by 3 minus 4 minus 4 root 3. Now we are interested in the integral 0 to pi of root over 1 plus 4 sine square x by 2 minus of 4 sine x by 2 dx. Observe that this is clearly a perfect square. This is in the form of 2 sine x by 2 minus 1 the whole square. So that makes it 0 to pi modulus of 2 sine x. What is under root of x square? Mod x. So that gives me mod of 2 sine x by 2 minus 1 dx. But then this modulus has to be resolved. That is, this will be, whenever 2 sine x by 2 is less than 1, it will be 1 minus 2 sine x by 2, and whenever 2 sine x by 2 dominates 1, it will be 2 sine x by 2 minus 1. So let's see in what interval. So we'll have to break the domain. 0 to pi interval has to be broken up. Your x is between 0 to pi, so x by 2 will be lying between 0 to pi by 2. Now sine x by 2, 2 sine x by 2, when is it less than 1? Let's solve this within this domain. So that means what? Sine x by 2 has to be less than pi 1 by 2, which means that x by 2 will have to be actually between 0 and pi by 3, pi by 6, sorry. That is, x has to be between 0 and pi by 3. Because we are restricting ourselves to the interval x by 2 lying between 0 to pi by 2. When is sine x by 2 less than 1 by 2? Within the interval, so x by 2 should lie between 0 to, this is 1 by 2, this is pi by 6. So 0 to pi by 6. Sine x graph goes like that. So x actually should lie between, this is the x by 2 axis I have drawn here. So x by 2 should lie between 0 to pi by 6. So x should lie between 0 to pi by 3. So we break it up. So this interval has to be broken up. 0 to pi by 3, which is dominating which one? 2 sine x by 2 is dominated by 1. So it should be 1 minus 2 sine x by 2 dx. And within the interval pi by 3 to pi, we will have the reverse of it. That is going to be, that's going to be 2 sine x by 2 will dominate 1. So we'll have a 2 sine x by 2 minus 1 dx. Now these are the simple integrals to be calculated, and we will see that the option 2 is the right answer. 4 root 3 minus 4 minus pi by 3. That's the answer. Simple thing to integrate and apply the limits. So the main part here is how to resolve the modulus. So wait to break the interval so that I take the positive sign thing here. Yeah, that's the answer. Therefore the answer option 2 is the right answer.